Hello, AP Stats students. I'm really disappointed that we can't do this activity in person because I was actually going to have you do all of these things and we would record it and then analyze it. But unfortunately, since we are not in the classroom, we're just going to have to use our imaginations. So the first activity would be rolling a dice and recording the value that it lands on. And then the second activity would be tossing a penny towards a target. And I would do it maybe 5 feet away. And then we would measure the distance of the penny from the target. So how close did everyone get to the target? And then activity 3 was to try to stop a stopwatch exactly at 5 seconds and record the time. And then we would graph this. And now I want you guys to try to look at these 3 graphs and figure out which activity would most likely make this graph. So let's start with this one on the right. This graph is pretty flat, right? This is what we would call symmetric, but also it's very flat, okay? There's no bell curve or anything to it. So I would say that this would probably be activity 1, where you're rolling a dice and recording it, because each time you roll a dice, let's say this is the 1 column, so a dice has 6 sides. Each time you roll a dice, it's equally as likely to land on any of the numbers. So if each person rolled a dice 6 times, odds are we would end up getting a fairly similar number of times that it landed on each number. So we would say that this one is symmetric. Oops. And when you have a symmetric shape, the mean is approximately equal to the median. Okay, so we've got activity 1. Now let's look at activity 2, tossing a penny towards a target, measure the distance of the penny from the target. So I would say maybe down here would be a number of inches or something like that, where most people, if their aim is good, are going to get as closer to the target, and we might have some that are farther away, some people that are bad aims out here. So this one's probably going to be activity 2, aiming for a target. And this shape is skewed right. Now, when you have a distribution that is skewed right, you have these outliers that are higher that are increasing the average. So that's why we always use the median, because in this case, the mean is going to be greater than the median. If it's skewed left, then it would mean that the mean is going to be less than the median. And then that leaves the stopwatch activity, which would probably give us this nice bell curve, because if everyone's using their own stopwatch and trying to stop it exactly at 5 seconds, most people are going to be pretty close to this 5, right? So this is the number of seconds that we recorded that it stopped on. Most people are probably going to get right there in the middle. So the shape is, again, symmetric. And the mean is approximately the same as the median. This is our nice bell curve here. So number 2, here's the distribution of stopwatch times for 100 students. The mean is 5 seconds, and the standard deviation is 0.1 seconds. So what is the percent of the values that are within 1 standard deviations of the mean. So 1 standard deviation from 5 would be here at 4.9 and here at 5.1, because the standard deviation is 0.1 away from 5, which is the mean. So if you count up all of the dots that are in this section and this section, that's going to be more than 1 standard deviation away, and it's asking us for the percent of values within 1 standard deviation. So let's actually count what's in between those two.
What are those aren't metal though, they're like the white PVC. Oh, aluminum. Oh,
Okay. This is actually going to be 68. So 68 out of 100 are within 1 standard deviation. So that is 68%. What percent of the values are within 2 standard deviations? So this is going to be, now we're looking at 4.8 and 5.2. And if you count up all the dots within 2 standard deviations of the mean, it's 95 dots, or 95%. And then what percent are within 3 standard deviations of the mean? .3 would be out here, and 4.7 out there. So that is all of the dots are within 3 standard deviations of the mean. Describe the shape of this distribution. So let's look at the shape.
yeah, even if like if worse comes to worse,
Not perfectly, but it is
container over
roughly symmetric.
kind of by the like the baseball batting cage.
Okay, so
The,
this
like on the west field.
is what we call the empirical rule.
So I'm wondering, I think there's some baseball stuff in there, like maybe a freshman baseball. But I'm wondering if they can
68, 95, and 99.7. These are dashes. Where the empirical rule states that 68% of values are within 1 standard deviation, 95% of values are within 2 standard deviations, and 99.7% of values are within 3 standard deviations of the mean. And this applies to a normal distribution. So the shape of the distribution is symmetric, which is approximately normal. So what we're talking about with normal distribution is the total area under the curve. So 100% or 1.
like the nicest person.
And the standard notation for this would be n with the mean, which is 5, and 0.1, which is the standard deviation. So let me just notate in here these points in the graph that we marked before, that here's our mean, and we use this Greek symbol mu. It's kind of like a cursive U with a longer starting point. So that is our mean. And here is mean plus 1 standard deviation, and we use the lowercase sigma symbol for that. So standard deviation, we use this symbol. Mean, we're using mu. And then here is the mean plus 2 standard deviations, and then out here is the mean plus 3 standard deviations. Going in the opposite direction would just be the mean minus 1 standard deviation, and so on.
Yeah, it's unnecessary.
So here are our quick notes.
They should. I guess I haven't looked. I know at least our freshman schedule. There's only
Density curves for a normal distribution. Total area equals 1.
I don't know if someone is going to have 3 less.
And the area is the proportion of values, those percentages that we were finding.
For the guys, that's what I'm thinking it will be for the pros too. Because if they want to be competitive at either of those, they're going to need numbers. You should have them.
For a distribution that's skewed right, the mean is greater than the median. For a symmetric distribution, the mean is approximately equal to the median.
They still have that one.
And if it's skewed left, the mean is less than the median. Our learning target number 2 is the empirical rule. Sorry for the noise in the background. So I'm going to do my best to draw this here. I'm not the best artist. I'm going to draw, oops, our normal curve here. I'm going to try to make it as symmetric as I can. So if here's our normal distribution, right down the middle is our mean. Mu is what we notate that with. Then you have 1 standard deviation, 2 standard deviations,
Yeah, I have him and I have Abraham.
and 3 standard deviations.
Well, all 3 of those guys aren't very.
And we're just going to pretend that my drawing is perfectly symmetrical. Okay, so the total area within 1 standard deviation is 68%. The total area within 2 standard deviations is 95%.
Okay.
And within 3 standard deviations, 99.7%. So remember, this is the mean minus 1 standard deviation and the mean plus 1 standard deviation, and so on.
Trying to think who his sister.
Okay, I'm going to go through the check your understanding with you. So the distribution of waist circumference for women who are 8 months pregnant is approximately normal, with a mean of 44 inches and a standard deviation of 4 inches. Sketch the normal curve that approximates the distribution of waist circumference for women who are 8 months pregnant. Label the mean and the values that are 1, 2, and 3 standard deviations from the mean. Okay. So, let's draw a normal distribution.
Size, you know, little Aaliyah. Size, curve.
So here's our mean. 44 inches is the mean. So let's write out what each standard deviation will be. So we are going 4 inches in each direction. So we have 48 as our one standard deviation, and in the opposite direction, 40. And then 2 standard deviations away would be 52 and 36. Just pretend those are perfectly spaced. And then 3 standard deviations is going to be 56 inches, and in the other direction, 32 inches. Okay, so a waist circumference greater than 52 inches may indicate excess amniotic fluid. What percent of women who are 8 months pregnant may have excess amniotic fluid? Show your work. Okay, so here we need to be looking at the percentages that are within those segments. So if within 1 standard deviation, this whole thing across is 68, then we know that this side's 34% and this side's 34%. Okay, you're just cutting it in half. And then if this all the way across is 95, then you would subtract 68 and divide that by 2. So that would be 13.5% and 13.5%. And then the next one within 3 standard deviations, you would do the same thing, subtracting out what you've already notated, and you end up with 2.35%. And then beyond that, beyond 3 standard deviations in either direction is going to be 0.15%. So we want to know a waist circumference greater than 52 inches, what percent of women may have excess amniotic fluid? So let's see, greater than 52 is going to be from here over. And we already know that this is 95%. So if that is 95%, then this whole section plus this whole section equals 5. So, right, because we have 100%, 95 would be 5%, but half of that is on the other end. So half of 5% is 2.5%. That's what would make up this section over here. We also could have added those 2 numbers together. Okay, about what percent of women who are 8 months pregnant have a waist circumference between 36 and 40 inches? Show your work.
Which isn't a bad thing.
So we've already done that work. actually. We've already done the math and figured out that between 36 and 40 is 13.5%. But you also could have done the 95% minus the 68 and then divided that in half, which is exactly how we got that before. So that's your lesson for today. Continue to review for the quiz we're going to have. This lesson will not be included in the quiz that we still have to take when we come back to school. If you have your textbook, I have some practice problems that you'll need to do, and I've put that in the Canvas page for you.
She like took over.